For this experiment, we require sodium thiosulphate to prepare 0.1 normal sodium thiosulphate solution, potassium dichromate to prepare 0.1 normal potassium dichromate solution for the standardization of sodium thiosulphate solution, sodium hydroxide to prepare 0.5 normal NaOH, solid iodine to prepare 0.1 normal iodine solution, potassium iodide to prepare 5% and 10% Ki solution. You are provided with a honey sample solution in a beaker bearing your table number. Warm the distilled water in a beaker. Dissolve the honey in warm water. Transfer the solution in 100 ml of standard measuring flask and dilute up to the mark by using distilled water. Pipette out 10 ml of diluted honey sample solution in a glass stopper bottle. Again pipette out 10 ml of diluted honey samples solution in another glass stopper bottle. Now measure 5 ml of 0.5 normal NaOH in a measuring cylinder and add 5 ml of 0.5 normal NaOH in the glass stoppered bottle. Now to each glass stopper bottle add 25 ml of 0.1 normal iodine solution using a burette. Do the constant shaking while addition of iodine solution. Now place both the bottles in dark for half an hour. Before placing them, moist the stoppers of both the bottles by using 5% Ki solution. Keep the bottles in dark for half an hour. Now weigh 0.49 gram of potassium dichromate to prepare 0.1 normal of potassium dichromate solution. Transfer the weighed quantity in the beaker. Dissolve it in minimum quantity of distilled water. Dilute the solution in 100 ml standard measuring flask by using distilled water to get 0.1 normal potassium dichromate solution. Stopper the flask and shake vigorously to get homogeneous solution. Now fill the burette with 0.1 normal sodium thiosulphate solution. Remove the air bubbles to release the solution suddenly by opening the knob. Adjust the zero level. Now pipette out 10 ml of 0.1 normal potassium dichromate solution in 250 ml conical flask. To the same solution, add 2 ml of concentrated SCl. Measure 10 ml of 10% Ki and add it also in the same flask. Shake the flask. Add 2 drops of starch indicator. Titrate the content of the flask with burette solution, that is with 0.1 normal sodium thiosulphate solution, till the end point brown to green or brown to blue. Note down the burette reading. It is 10.2. Note down the burette reading and take one more readings to get constant burette reading. Here CBR is observed to be 10.2 centimeter cube. Calculate the normality of sodium thiosulphate solution by substituting the value of X, that is CBR of standardization part. So 10 into 0.1 divided by 10.2, the normality of sodium thiosulphate comes to be 0.098 normal. Now take out the reagent bottles from the dark. To it add 5 ml of 2 normal H2SO4. Shake the bottle vigorously. Add 2 to 3 drops of starch indicator to the same bottle. Shake the bottle and then titrate the liberated iodine against burette solution, that is standardized 0.1 normal sodium thiosulphate solution, till the end point brown to blue, blue to colorless. That is, the final end point is brown to colorless. Note down the burette reading. It is 19.9 ml. Take one more reading to get CBR or MBR. The second reading is observed to be 19.9, hence constant burette reading 19.9 centimeter cube. Note this reading as Y. Now to perform blank titration, pipette out 10 ml of distilled water in 250 ml conical flask and do the similar procedure for the same part as like estimation part. That is, add all the reagents to the same conical flask, but only take 10 ml of distilled water instead of 10 ml diluted honey sample solution. Measure 5 ml of 0.5 normal NaOH and add it into the same flask in which 10 ml of distilled water is taken. Now to the same flask add 25 ml of 0.1 normal iodine solution. Do the stirring continuously while doing the addition of iodine solution. After completion of addition of 25 ml of 0.1 normal iodine solution, add 5 ml of 2 normal S2SO4. Shake the flask. Add 2 to 3 drops of starch indicator to the reaction mixture. Shake the flask and titrate the content of the flask with burette solution, that is standardized 0.1 normal sodium thiosulphate solution, till the end point brown to colorless. Remember, in the blank titration we are adding same reagents used in back titration, that is estimation of glucose. Only the change is that instead of taking honey sample solution, we have taken 10 ml of distilled water. Note down the burette reading. Note down the burette reading, that is 28 centimeter cube. Take one more reading to get constant burette reading. The second burette reading is observed to be 28 centimeter cube. Hence, constant burette reading is 28 centimeter cube. Note this CBR as Z centimeter cube. Let's do the calculation. In the estimation part, CBR for back titration is 28 centimeter cube. That is volume of 0.1 normal iodine solution added to honey solution in terms of standardized sodium thiosulphate solution is equal to 28 centimeter cube. While the CBR for blank titration is 19.9 centimeter cube. That is volume of 0.1 normal iodine solution remained unused in terms of standard sodium thiosulphate solution is 19.9 centimeter cube. Therefore, volume of 0.1 normal iodine solution used up for the oxidation of 10 ml of honey solution is Z minus Y, which is equal to 28 minus 19.9 equal to 8.1 centimeter cube. Therefore, 100 centimeter cube of honey solution used up 10 ml of sodium thiosulphate solution. From stoichiometric equation of iodine against glucose, 1000 centimeter cube of one normal sodium thiosulphate solution equal to 90 gram of glucose. Hence, 10 C centimeter cube of standardized sodium thiosulphate solution is equal to 90 into 10 into 8.1 into 0.098 upon 1000. That is 0.714 gram of glucose. Let's calculate the percentage of glucose in the honey sample, which is equal to amount of glucose present in the sample divided by weight of honey sample into 100. The amount of glucose in the sample is observed to be 0.714, while the given sample of honey to the student is 2 gram. So 0.714 divided by 2 into 100 is equal to 35.7% of glucose in the given sample of honey. Let's calculate the percentage error with respect to percentage of glucose in the given sample of honey. Percentage error is equal to xi minus xt upon xt into 100. It is observed to be minus 6.0526%. Hence, the final results are: normality of sodium thiosulphate solution is 0.098 normal, volume of standardized sodium thiosulfate solution consumed by given sample of honey is 8.1 centimeter cube. Amount of glucose present in the given sample of honey is 0.714 gram. Percentage of glucose present in the given sample of honey 35.7%, and the percentage error is minus 6.0526%.